Hello, hello, this is Postgres FM. I'm Nikolai from Postgres AI, and as usual, my co-host is Michael from pgMustard. Hi, Michael.
Hello, Nikolai.
So, I chose very boring topic, and we talked about it a lot. I hope this is the last time we were going to talk about it, maybe, right? Buffers, or pages, or blocks, or how to name it, depending on the perspective you have, right? But buffers, episode 3. Or which title are you going to choose on?
It's like the third in a trilogy, isn't it? Maybe it's like Return of the Buffers or something. I don't know.
Right, but we have a few reasons to revisit this topic today. Of course, this topic has been very heartwarming for me, I would say. For a couple of years, we discussed how important it is to consider buffers when optimizing queries at micro level, when we talk about explain, analyze, comment, or at macro level when we talk about register statements and other extensions, and aggregate everything and see parts of workload or the whole workload. And recently, finally, as we already mentioned a few times, buffers were added to explain analyze by default after a few unsuccessful attempts from previous years. I think it was David Rowley, right?
Yes, and Guillaume Lalage played a big part as well.
Right, and all previous hackers also who made even unsuccessful attempts made some shift into this direction. Of course, it's really small technical change. So now you don't need to write the word buffers. You just write explain analyze, and as a reminder, explain just provides a plan for the query, which planner is going to choose, optimizer is going to choose, and then explain analyze actually provides both the plan and actually execution. It actually executes the query, so you see more data. And by default, buffer information, buffer hits, reads, buffers dirted and written were not present in the plan. And that was a bummer for us who dealt with queries at scale, right? So because this is important information, as we discussed, and we will discuss again, I think. But now in Postgres 18, you don't need to write buffers explicitly. This information will be included by default. And that's great. That's great. I think it's a super important small change which will affect lives of many engineers. Because
I think just worth. I know you've alluded to this already. It is an upcoming version of Postgres 18. It's been committed, and things that get committed have a very good chance of making it to the final version.
99%.
But things do get reverted, so there's a small chance we'll still have to talk about this more in future. But yeah, we already had the ability to request buffers. We could already add, explain, analyze buffers and other parameters. But a lot of the time when people are asking for help online, or when people set up auto-explain, although I see buffers more in auto-explain, I don't know what your experience is. But yeah, when people are asking for help, or people are writing blog posts, or people are just getting familiar with Postgres, they'll come across explain analyze and then not know that buffers exists, or not use it when it would actually have shown the issue. So there's a bunch of cases where by having it on by default, we'll be able to help more people online when they first have an issue without having to ask them to go back and get another query plan, or it'll just be more likely to be it will be in those query plans by default if they're on Postgres 18 or newer.
Yeah. And I know you have also opinion, and I agree with you that some other things should be included if we provide something like all or verbose. There is verbose, but it doesn't include everything, and this is slightly strange and unexpected if you don't know details. But let's focus only on buffers.
Yes.
Yeah. It's really hard for me to imagine it will be reverted. It might be, but I think, yeah.
I could just imagine this aging really, aging like milk, we say sometimes, just in case. I just wanted to make people aware that might have happened.
Yeah, so we talk about Postgres 18, which is going to be released this fall in many months, and it will hit production only in a couple of years, on average, maybe. or maybe even more. So it's still in far future, in distant future. But I wanted to just think in advance, since we are both building some tools and methodologies and everything. I wanted to think, is it going to have some positive effect on how we are going to optimize queries in the future? And if, for example, defaults matter a lot at scale. And I learned it building 3 social networks in the past. If the simple lesson I remember, some spammer was sending, on behalf of administration, was sending the message, send text message to this number, without any reasoning. And if you send it to 1 million people, there will be some people who will follow. Because, why not? Of course, if you add some reasoning, it will work even more. So defaults matter a lot, and we can put everywhere words like don't forget buffers. But if it's still if default behavior remains without buffers, there will be a lot of people who will not use it, right? And this is what we see. If you go to explain Depeche.com, it has history. And of course, actually, even explain Depeche.com also advocates for buffers since not long ago, which is great. But if you just check history, you see a lot of plans provided without buffers, right? Because defaults. Now we have good reason to expect that after a couple of years we will see majority of plans with buffers. Do you agree?
Yes,
because
maybe not in the full, but maybe definitely in 5 years' time, maybe in 2, 3, 4 years, it will become the majority.
Well, let's say if it will be 18 plus version, this plan, again, 99% or even almost 100%, it will include buffers because only few people will bother turning it off.
Oh, I meant actually people still running very old versions. More likely. Yeah.
But imagine we're already thinking about people with new versions, and I think we will have buffers. What does it mean for analysis? Are we going to highlight this information or use this information even more intensively? What do you think?
Well, good question. I think people will ask. People already have lots of questions when looking at explain, analyze, output for the first time. And people are like, what does this statistic mean? What does that statistic mean? And I think buffers are another kind of one that at first people are a little bit confused by. What does it mean? What is that number? Is that a lot? Is it not a lot? What unit is it in? All these kind of questions. So I suspect it will immediately in people's heads have a bit of extra confusion. But once they're familiar, I can't see how it isn't helpful. It's just going to be so helpful, especially once people people and tools start converting that into data volume sizes. I know it's an imperfect, but let's accept the imperfection of timesing it by 8 kilobytes. So each buffer being a page and multiplying it by 8 kilobytes, you get an idea of the data volume being read. When people see a query and notice it's reading a gigabyte of data, even if it's from shared memory, when it's not using an index or when it's using a specific index, and then it's only using a few kilobytes when it's using a different index, suddenly they realize the index is helping speed things up because it's more efficient, because Postgres is only having to read far fewer blocks, much less in order to serve that query. I think it becomes a lot more intuitive that indexes help because they're a more efficient way of running certain queries, not their magic. And I think there's currently, not amongst kind of Postgres folks, but definitely in the developer community as a whole, there's this perception that indexes are magic. And I think buffers being present is like a good step towards, no, they're not magic. They're a very clever idea that makes things really simple.
Yeah. Yeah, that's a good point. I was listening to you and thought I'm contradicting to myself when I say buffers hit and read and written and dirtied. It's incorrect. It should be operations. Buffer reads, hits, writes, and I don't know how to deal with dirt.
Right? Dirties? I don't know.
Yeah. Pieces of dirt, right? No. actions of Dirt. But anyway, like I'm saying, these are operations, and if you sum up some numbers, it might be the same buffer which you are hit multiple times, right? Not sure about other operations, but hit we definitely have in the nested loop. We can have hits for the same buffer many times.
Yeah.
But when you say we need to convert, I totally agree. I did it for long. Like I noticed it very long ago. Once you convert it to bytes, megabytes, gigabytes, sometimes terabytes actually.
Yeah.
TB bytes, right? GB bytes. Once you convert it, engineers have a aha moment. Always. I mean, those who see it first time, because 100 buffer hits or reads, 100 buffer reads is nothing to them actually. It's what it is, hard. But once you say, okay, we read 800 kibibytes to return a number of like 8-byte number, you can feel it already how much it's just to return 1 byte you are reading 100 or 800 how many kibibytes. Each kibibyte is 1024 bytes. Wow, like it's not very efficient, right? How about having, I don't know, like hash or hash table or something to find this number, and then okay, this is why, like because it's a sequential scan, and this sequential scan is just scanning whole table. If we remember big O notation, sequential scan has terrible performance because so many operations, and it also depends on the size of each tuple, how many tuples are present in one 8 kilobyte block, 8 kilobyte buffer, right? So if only a few tuples there, we need to read a lot of data from memory or from disk. So once you switch to a B-tree index, it becomes only a few buffer operations. Even if you have a billion rows, it will be like 7. I don't remember exactly, but it's like 7 buffer hits. That's it. And even they are still like 8 kilobyte. It's a lot, but it's already much better than if it would be sequential scan, which is insanely slow in this case. And you think, that's why it's slow, because we deal with huge volumes of data. And when we apply index, we suddenly deal with very low volumes of data, right? And this is number one reason why database becomes fast. This is how indexing works. Like we just reduce the number of I/O operations. And when I say I/O operations, I often include operations with memory hits, because we know operations with memory versus operations with disk. It's like 1,000 times difference. It's of course a lot, but still, like we can compare it, and one read is roughly like 1,000 hits to memory, right? Unless this read is also from memory, from the page cache. In this case, it's all very, very, very similar, right? So what I'm trying to say, we talked about this reasoning, and I agree with you. We need to convert to bytes and present it. At the same time, we need somehow like have some remark that these buffer hits might be like to the same buffer. It's not only it's a volume. It's some abstract volume of data. We can have like kilobyte or megabyte of data hitting the same 8 kilobyte buffer, right?
Yeah.
So it's okay. But comparing volumes of data, it's so good because first of all you start thinking about data volumes, which is number one reason of slowness, especially if we forget about concurrency, right? Because concurrency is a different topic. If we take just one query, there are cases when it can be very CPU intensive workload, but in the majority of cases it will be IO intensive workload for one query for databases, right? And our goal is to help Postgres with indexes, with maybe some redesign, to help index to deal with as few operations with memory and disk as possible. And it means we need to focus on buffers.
Yeah, are there any? I think there might be a few other exceptions, but I think they're more. Yeah, I don't think that. Well, maybe it's only one. I think maybe it's CPU as well. Actually, I was thinking JIT compilation. What that's probably
well,
CPU
we had
again, isn't
recently
it?
we had
Yeah.
recently discussion about RLS, and
Mhm.
there
Oh,
we
yeah.
had inefficient, fully in memory work, CPU work, like check some volatile function or stable function also, right? So it's if it's in loop for all rows, it's CPU intensive work, which is
Yeah,
not
there
good.
have been. I was just trying to think. There have been a couple of other times I've really not been able to spot issues by looking at buffers,
Yeah.
but they're not actually. It's not because Postgres isn't reading data. It's just it's not reporting it in explain analyze yet. So actually, maybe getting it on by default will encourage some more reporting of buffers as well. So for example, I don't think triggers report the buffers read. Like if you have, you know, the famous case of not indexing a foreign key and then having on cascade delete, like that trigger might tell you it's taking many seconds because it's having to do a sequential scan of the reference table, but no buffers reported as part of that. Same with in-memory operations like sorts or hashes. Like they could be really slow even though they're done. Maybe you've got quite large work mem and maybe it's the dominant part of the query plan, but no buffers reported as part of that because it's in memory. It will report the buffers if it spills to disk, but for reads of tables and indexes, we get reports even if it's from memory. But for operations like sorts and hashes, we don't get. But so there are a few things that are still doing work that it would be good to get those. But it's not. It doesn't go against what you're saying in principle. It just means I can't use what Postgres is actually giving me in explain analyze buffers to actually diagnose the issue there.
Yeah, I remember also touched the topic that it would be really great to see details for buffers. For example, how many buffers from heap, from index, maybe distinguish in each index, some details to see. Because if we go back to the original approach for dealing with explain analyze, and I see it like even many hackers, blog posts provide plans, analyze plans, but they don't use buffers still. I hope this will change, of course, over time.
Yeah.
So usually, okay, we have time. We try to guess, okay, this time is lost here. Why? Okay, because sequential scan. But in terms of data volumes, what do we have? Only rows, right? Expected and actual rows. Logical rows. And sometimes we think, okay, we fetch one row here.
Oh, we get width as well. An average estimated width.
Okay.
Which is
times
by rows gives you some idea, but it's only the width of what's being returned, not the width of what's being read.
Exactly. This is like, okay, yeah, we can multiply width by rows, get basically number of bytes, but it will be like logical level, and underlying level might be very different, drastically different. For example, if there is a lot of dead tuples, which Postgres checked to return this very row, right? Maybe it checked 1,000 dead tuples, and it's hidden if we look only at rows and timing, and we have no idea why timing is so bad, right? Okay, returned one row index scan, but why so bad? Here's why. We go to buffers and we see that a lot of buffers were hit or read. I don't know. Doesn't matter. That's why timing is bad. And then my point is that like it's already very useful, but imagine if we saw, actually from this particular index, from this particular table, we got those operations with buffers. It means that to return this row, so many buffers, even with index scan, it's bad. Oh, that's why, because it's bloat. This row had many versions, not cleaned, and index scan needs to check heap table to get version information. So this would be useful to like detailed buffers, to have detailed buffers maybe, right? And
I had this case recently. I was in January, I was doing some office hours calls just to get an idea of what kind of issues people were facing. And I had some really good conversations. Thank you to everybody that jumped in on those. But one of them, they were using our tool PG Mustard, and it was one of the tips we show people is we call it read efficiency, to look for exactly that. When are you reading lots of data? And we actually, for long-term users, used to call it table bloat potential or like bloat potential. So it could be index bloat, could be table bloat. But we renamed it read efficiency a few years ago because there are other possible causes of it as well. So it is a tricky one. And because we didn't, so this office hours call, they were hitting quite a few read efficiency issues, but they couldn't diagnose exactly where it was. Like, was it index level? Was it table level? They looked at both. They didn't seem bloated. They re-indexed. They tried a lot of the things and couldn't reduce it. So it was a really interesting call. But that's my first port of call is, and this used to be true more in older versions of Postgres, but indexes can get extremely bloated. So can tables in some cases. But yeah, it's amazing that you can suddenly see that by turning on buffers. And that is something I wasn't expecting to be true, because I see bloat as kind of like more of a system-wide issue, but to be able to spot it in query latencies was really cool.
Oh, bloat can be very tricky. Sometimes we have, with our consulting clients also, we have like bloat is low, but some query suffers. And it turns out that like, we call it usually local bloat. So for particular IDs,
yes,
the situation is super bad. It can also be not a bloat, but some, like sparsely stored records. They are like distributed among many buffers. And you expect, okay, I have very narrow table, only like four or five columns. I expect a lot of tuples to be fit inside one page.
Yeah.
But somehow reading 1,000 records, rows, I deal with thousands of buffer operations. What's happening here? And if we just check CTID, we can understand that each row is stored in each particular page, so we have a lack of data locality here, and so clustering with pgdpag without downtime could help, or so partitioning helps usually in such situations, and so on. Yeah. So in buffers, exactly the way to feel all these problems better. But I agree. I like your idea to talk about read efficiency and maybe write efficiency as well, because for end user it's obvious. Okay, I return this data. I return only 25 rows on my page, so I expect not gigabytes of data to be fetched from buffer pool or even worse from disk, right, or from page cache, which is between disk and the buffer pool. So I expect maybe only like some kilobytes, right? Maybe tens of kilobytes, even not megabytes if it's quite narrow table.
Yeah.
Why Postgres should not do a lot of work to show 25 rows. If it does a lot of work, something is not right, and we need to optimize this query. And without buffers, we only can guess. With buffers, we see it, right? With buffer details, would be even better, right? Someday maybe we will have detailed buffers. So per each database object, some statistics would be interesting, I think, to observe. Yeah, and there is criticism of this approach. I recently had interesting discussion on Twitter, on X, and somebody told me that in Oracle there is the ability to flush caches, right? And in Postgres it's tricky. Usually it means we need to restart Postgres to flush the buffer pool, and also to echo 3 blah 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 to flush Linux caches if you want to go hardcore and very cold state, to check very cold state. And this is interesting.
I think you can restart.
Restart what?
The data, like if you're testing locally, for example, or on a clone, if you restart the database, doesn't that reset caches?
Restart of Postgres will make empty only the buffer pool. But we also have, if it's Linux, we have also page cache, right? Yeah. We can flush page cache with simple command. Of course, if you have sudo.
Yes.
Right? So it's easy. I always Google it, echo 3 to some path and then sync, and that's it.
If you're on a managed service, what's the best you can do?
Well, managed service, you cannot do this, of course, right?
But restart is like, I think,
reboot.
The best you can do. Reboot, yeah,
reboot. Well, this is hardcore. So let's talk about this. I also see a constant desire to check the cold state in database lab we build. Some users use it for query optimization with some bot we have, Jobot, very old stuff, but it works really well for query optimization and also like experiments, right? So you can check on ThinkClone, on Branch, you can check various ideas. And there people say, okay, I see the hot state. Data is already cached. I want to check the cold state. And I think it's natural desire, but yeah, well, every time we say there is no such easy way. And interesting that, I didn't know, but interesting that in Postgres 17, in PG buffer cache, there is a new function, PG buffer cache evict, and you can try to use it. I think we are going to try it at some point when Postgres 17 will be more present on production systems. We probably will consider adding this to make the buffer pool empty, right? But unfortunately, this function, I suspect it won't work really well. It's definitely not for production, first of all, right? It's for like lab environments we build. And unfortunately, per documentation, it won't evict buffers which are pinned by, for example, vacuum process, and so on. So in some cases it will fail. We will need to think how to deal with it. Of course, restart is definitely working in this case. So if we think about why do people need cold case at all, what's your opinion on this?
Well, I think it's coming from a good engineering rationale. You know, I want to make sure the worst case isn't too bad, or, you know, like it's definitely, you want good engineers to be thinking about edge cases, to be thinking about the worst possible case. But I also think that in practice, the kinds of optimizations we're doing here, the whole point of the discussion here is we're saying try and reduce the amount of data being read to as minimal as possible. If it's an important query, try and get a very, very good access path for that query. And that will involve getting the buffer numbers down as much as possible, whether they're cached or not. And therefore, and maybe you want to explain to people in the PR, or you need to explain to your team how much faster has this made it. So I can understand wanting to compare cold cache state to cold cache state and then having these kind of relative differences. But I would encourage going the opposite route. It's much easier to work with warm cache, especially when you're doing query optimization. You're naturally going to warm up the cache if you're running the same query over and over again. So I would encourage more going the opposite direction and say, compare
OLTP.
Yes, this definitely applies for OLTP, but even for OLAP or OLAP queries, I don't see the downside of saying to your team, it's still explain analyze, right? If you're showing query execution plans before and after, which is often what people are doing, kind of show this is what it was, this is what it will be. It's already imperfect in terms of reporting numbers. It's not exactly the same as what the client's seeing. So if we're already imperfect, I don't see the downside of comparing warm cache to warm cache. So I tend to run things a few times, get the
before optimization and after optimization, we compare two cases. Both should be warm. And we focus on not even if we have reads still, for example, buffer pool may be smaller. In lab environment, we usually have much smaller of a buffer pool because we run multiple Postgres instances on the same machine. It's shared environment. So if you deal with large volumes of data, it might not fit the buffer pool.
Yeah.
So you are going to see reads. But the idea is let's just summarize reads and hits, maybe even writes and dirties, how to name it, right? So all four buffer operations, if we just summarize it and use it like as universal metric, this is now our number of, or just maybe reads and hits, depends, right? So but in overall, we just see this is overall volume of data, and this is what you return, 25 rows.
I like that a lot. That's exactly what we do. But I get the sense that what people really want is to compare timings. So they want to say this query that used to take, because sometimes it's coming from a complaint, right, or something. This query that used to take 20 seconds now is 500 milliseconds. Or this query that used to be 200 milliseconds is now less than a millisecond. So they want this kind of like difference in timing, even though behind the scenes it's a difference in buffers. So for that, if you want kind of apples to apples comparison, instead of trying to get cold and be fair on the cold side. I'd just say it's easier to be fair and do it on the warmer side. I know it's not perfect, and it might be that your real users are hitting the cold cache state, but if that's what you want, that's the direction I would go.
Yeah, well, we have slightly different methodologies here. I usually say, okay, we start from the statement, the query is slow, it takes like 30 seconds or 1 minute. It's super slow, unacceptable. We want it below 100 milliseconds or 10 milliseconds, right? Mm-hmm. And then I say, forget about timing for now, completely. Focus only on buffers. If we check buffers and see a low volume, 100 buffers, 100 buffer hits and reads, to return 25 rows, we know our micro-optimization is over. We need to go and see the whole picture, what's happening with concurrency. Probably we have some, maybe this query is waiting on log acquisition of all those seconds. Yeah. That's it, right? So it's already this. But if we confirm large volumes of data, we forget about time. We focus only on we focus on obtaining sane numbers for buffers. Sane means, okay, hundreds, thousands, not more. Even thousands to return 25 rows, it's already quite a lot. And we must do it. Sometimes, of course, it's not easy. Sometimes we need to do denormalization, some complex surgery on our database, and involving like long-lasting operations with backfilling and so on. But once we achieve this, in most cases, we can have same number of buffers, and then we say, okay, now we can compare timing. And comparing timing in lab environment, it still might differ from production.
Yeah, of course.
But of course, I know, I use it as well. I say, we improve timing 100,000, like 10,000 times. It happens, right? And this is good for final comment, in the end. But only when we did work on buffers fully, right?
Given it's you could, with your reputation and your teachings, you could leave that last line as we improved buffer read or
read efficiency, for example.
Read efficiency, exactly. And it would be probably almost the exact same number.
Not necessarily, but maybe.
You'd be surprised how often it's close.
Okay, good. Yeah, that's good. Maybe I should think about it and also present this information during consulting activities and in tools as well. Yeah, I think it's good. So yeah, read efficiency, and you take number of rows and width and just multiply it, get bytes from there, and then.
Yeah, it's a tricky one because like different scan types, you expect different amounts of efficiency. So yeah, it's slightly
involved, not involved. Also interesting, right?
Yeah, but I think the main differences are sequential scan. Like sequential scan is very different from sequential scan and bitmap scan have some similarities. Index scan, index only scan have some similarities, but then like looped index scans are somewhat different to like range index scans in terms of how many tuples. Like in a loop, for example, you can't get fewer than the number of loops. Like it has to do at least that many. Mm-hmm. So yeah, there's some subtlety, but yeah, that's it essentially.
Yeah, but back to the cold state, I also agree. Like I can imagine you would need it, and unfortunately, it's possible, as I see, only in lab environment where you are alone, because this is a global operation to flush operational system page cache, for example,
and where you control the hardware, right? Or like the VM.
If it's managed situation, again, restart, as you said, also an option. But again, this also only works if you're alone, and this is expensive. We aim to make experiments super extremely fast and cost efficient. So it means managed environment. Many people work on the same machine. So if one decides to flush everything, others will notice, right? And with this function, pgBuffer cache evict, I think if we manage to make it work, I see it's useful. Even imagine if we have page cache, or in the case of DBLab, it's ZFS arc, which is common for if one block is cached, it's cached for all clones, all branches. It's very good in terms of efficiency. So But sometimes, indeed, engineers want to check inefficient situation. Okay, in this case, I think what we would do, we try to, if user requests for their particular database, particular Postgres instance running on this machine, we can ask to evict maybe everything from buffer pool or for particular tables and indexes, say everything. And if we succeeded, there are chances that same these buffers are cached in underlying cache, right? Page cache or arc. In this case, query timing is not going to be very different, but plans will be different. We will see reads instead of hits, right? Observing buffer numbers, we will see the difference. Okay, reads now, not hits. And what I'm thinking, in this case, we could consider it like relatively cold, this situation. And
lukewarm.
Yeah. And we could just say, okay, we know that reading from disk is roughly 1,000 times slower than from memory, right? So we could do some estimation of real cold state.
Well, or there's that. How often do you see clients having track IO timing on?
All very often. Mm-hmm.
Great.
Yeah.
Okay, that's really positive. But because that gives us an idea of how long those reads rather than hits took, and you could do some division of reads by IO timing to get an idea of where they're coming from. I think there might also be some work. I think I saw something either in a commit for Sentry or a hacker's thread to try and get the details of is it. Yes.
It's like pg.k-cache for micro level, right?
Yeah.
Yeah. Well, it's possible if you have access to everything. It's possible from proc process number IO. You can get it from there, I think.
But it would be good to have it in Postgres core so that we could even get it from managed services, for example.
Yeah. Well, there is something that can be done here, and improved observability of and work with particular query if you have control. Yeah. But I'm trying to say, like, even if with this evict, we can get some interesting information, even if we cannot allow ourselves to reset the whole everything, including page cache. So it already can be useful in non-production environments to study the query behavior if it's a clone. Yeah. So I feel there's a lot of things that can be improved in this area to work with queries, and especially it's important to continue this work because I suspect we will use some tools to work on this at massive scale. Like, for example, if we fetched we already now during consulting, we did it with few clients. With AutoExplain, we fetched a lot of queries, some hundreds usually, sometimes thousands. It's insane.
Nice.
Examples with plans. And then, actually, because we partnered we in some cases we use pgmustard to provide additional insights, which is great. And then we have a lot of stuff. Unfortunately, I still don't see how to avoid human here. I like to involve human there, but I would like to involve less, because usually right now we have a lot of cases of query analysis like that, and then we need to draw some common picture from it, right? And this like going above all those plans and say, okay, we have a pattern here, for example, bloat is obvious, or something like this, or index health is not good. And to draw this picture, human is involved heavily right now. I'm thinking like over time, probably we will build some additional like macro level analysis for micro level cases, or hundreds or thousands of them, and this is going to be great. And then looking at buffers, and actually we have buffers there as well. You're right in AutoExplain. Timing is not present. People are afraid of overhead. Buffers also have overhead, but kind of smaller, right? And we had articles. You had articles about this as well.
Yeah.
So so the cold cache is tricky, and there is this function. That's it. So Postgres 17 plus. What else? There is macro level, right? And at macro level, we can talk about PG style statements. PG blocks read, hit. By the way, there it's Yeah, also naming. We talked about it. It's also naming like it's like data volumes, but it's okay. And so read, hit, written, dirtied for shared buffer blocks. In pgstat statements, also there is pgstat-k cache if we want real disk I/O to be observed. And again, I advertise to include pgstat-k cache in any setup. It's a great extension. And there we can talk about some macro level, like, okay, this query ID has this volume per second, or this volume per query, or it's responsible for 90% of all hits to the buffer pool happening in database. Maybe it doesn't look super slow, but it's so intensive with shared buffer pool.
That's a good point. I almost always encourage people to look at their top queries by total time. Unfortunately, with pgstat statements at least, there's no kind of total blocks. Because it's split into these many steps, you could order by shared hit plus shared read and get a good sense of one type, or by dirtied for a different. But yeah, you'd have to sum in most cases I'm thinking of that would give a good like system-wide aggregation. You need to sum 2 columns, I think, to get a good
reads and hits, right?
Ordering, yeah.
Yes. So we usually it's underestimated approach with pgstat statements to order by sum of reads and hits.
Yeah.
It's super important. This is how you identify IO intensive queries. And now they can be mostly hits, but if database grows, they can be converted more and more into reads, right? Or vice versa, you are going to double your memory size and the buffer pool size, so reads will be gone, but just sum them and consider them together to understand how IO intensive the query is. And think, this query probably needs optimization, especially if it returns only 1 row or 0 rows, right? So, in this case, we can also consider buffer focused optimization, which is important. I think it's underestimated, but also it's worth mentioning this interesting blog post from Andrei Lepikov, right, who gave, I would say, hacker researcher perspective on this, right, saying, actually, I didn't mention that this is my point for sure for lab environments we build. It's important to say timing is super volatile. It's unpredictable. You can have timing one today, another tomorrow. One on production, another on a clone of production. Very different timing. And it will be a big question to track all reasons why timing is unpredictable. And there is a concept like there's a simple methodology. If we deal with complex problem, let's split it to pieces and analyze pieces separately. So when we take a clone and bring a single query and optimize it, we already get rid of concurrency issues, heavy locks, lightweight locks, everything, like forgetting about them. And we deal with a single query alone in one clone. And it's already super good. But we still need to have something like reliable in terms of metrics to optimize. And timing is not reliable because it's unpredictable. It depends on states of caches. If it's a shared environment, maybe CPU and disk are super busy and like there is noise from neighbors when we optimize in this case, right? But once you focus on buffers inside optimization, you have invariant metric. Okay, it can be reads versus hits, but to get some of it will be constant if you repeat the query. For this particular clone, for this particular query, these parameters, everything is the same. Plan is the same, right? So you have the same thing. It's repeatable, reproducible. This gives you a foundation for optimization, because without it, you have very shaky foundation, like not solid foundation, right? Timing. So, and then you optimize, and I like your idea about optimization, actually, I used it. I said, okay, 10,000 times timing, and I remember I mentioned buffers as well, but I didn't expect people will value this comment a lot. Maybe with buffers by default, we should push on this methodology more and more. But what Andrei is talking about in this article is that for research purposes and so on, instead of timing, maybe we should focus only on reads, right? And reads is something that could be a target itself for optimization and decision if the system works efficiently or not efficiently. Because we are talking about databases, and I/O is the number one thing in terms of what takes time. And I like this idea, yes. So like this is very close to what I see for many years building lab environments, non-production environments, which can help people scale their teams and databases and processes and so on. Yeah. So what's your opinion about this article?
Yeah, I thought it was good. I think this blog's great, but I think it's very hacker focused, and I think that's good, right? Like this is a good topic for hackers as well. There's a lot of blog posts I see from people often explaining performance issues and not including buffers, and it seems like a missed opportunity to educate on that front. So this is a great argument for the people doing the educating, I think, or even doing the implementations of why it can be helpful to see this. I think he makes some good points as well about hardware changing over time, and his initial paragraph is even about I can't reproduce
reproduce timing. Yes.
Yeah, because it's not just that. It's also and this is a different point slightly, but there's insufficient setup information, which is really common in benchmarks. It's really common to not include which exact machines were being used or so without that information, buffers can still be used as like this is interesting. Sure, there might be optimizations over time that Postgres can use fewer buffers for certain operations, or certain indexes become more efficient. There's been a bunch of work to optimize B trees in Postgres over the years, and I would expect that to lead to slightly fewer buffer reads in a bunch of cases, but they would be easier to see the differences in than timings. Exactly. And I think he's also got a really good graph here that shows that there's not zero variance in buffer numbers, but it's much lower, and it's way more stable than timings, and nearly completely stable with some exceptions, which is my experience as well.
Yeah. I agree, especially, for example, if you run the query first time, rel cache is not there. It will give you planning time. It will give you huge overhead and huge buffer numbers. But second execution will fully shave it off, right?
Yeah, so planning buffers. Planning buffers
is a separate topic. It's a very important topic. Yeah, I like we have it.
Me too, but I don't fully understand them yet. Like
what?
Why? Why do we get so many more in the first execution, and then why do we sometimes get none reported at all?
Okay. You mean yeah. I think we discussed it maybe. Not sure if I saw some very weird behavior in planning buffers. Maybe something is not tracked as well, as you mentioned.
I think it must
foreign
be.
keys. Yeah. So maybe we should dig into this topic and raise discussion about that. Yeah. So back to Andrei's blog post.
Yes.
I agree, and that I cannot reproduce, and we build lab environments sometimes very different from production just for the sake of cost optimization. Like if you have 360 core EPYC, 5th generation EPYC on production, and almost terabyte or more of memory, it doesn't mean you cannot optimize your queries on Raspberry Pi. You can. on magnetic disks, very cheap, and their query fully cached might be slow for you on production, might be like a second. You go and optimize, you understand you have shitty hardware. In this case, you just see, okay, it takes minutes or hours, but buffers are the same and plan is the same. You can make decisions on super cheap hardware with smaller caches. Everything is smaller, very slow disk. You can still make cautious decisions and move forward with optimization, find solution, see that you optimize buffer numbers like 1,000 times, and expect similar effect, maybe the same effect on production, affecting time accordingly, right? And this is the power of lab environments. I think everyone should have them. Super cheap, shared, so many people and CI pipelines work together, and focusing on buffers is magic, right?
Yeah,
It's
I
magic.
think it's easy. I think you're completely right. I think it's easy for people to make the mistake of then also not using sufficient data volumes. I know you don't. I know that's not what you're advocating for. But yeah, it's the data volumes that matter way more than the power of the disks or the specific CPU.
Yeah, usually people say, okay, we are going to have weaker hardware for non-production, and we are going to focus on relative optimization. So if it was a second in production, 10 seconds in this non-production, which is weak, we are going to optimize from there. But it's still weak because status of cache and so on. Like, just focus on buffers, and then you can understand it. Again, there are exceptions. I agree, such as we discussed with RLS and so on. It's possible that your particular case is CPU intensive, but these are exclusions from the main rule. Absolute majority of cases you will be dealing with buffers during optimization, right? So, congrats with Postgres 18 change, and I also want to thank Andrei Lepikhov for this blog post, which is very welcome. I think we need more posts about the importance of I/O metrics at various levels. One query level, micro level, or macro level, like PGSat statements, PGSat Kcache. So yeah, I hope this topic will grow and be more popular, this methodology.
Yeah, agreed. Another thank you to the people involved in getting this committed to Postgres 18.
Yeah.
Big thanks. Oh, and I think this might be our first episode since we both got Postgres contributor status, Nikolai. So congratulations to you. Yeah. And thank you to whoever nominated us or whatever the process is there. Thank you to everyone involved.
Good. See you next time.
See you soon. Bye.